Have a little look here. So I want to contrast this with what we talked about last. I think it was Thursday, Wednesday. Can't remember. One day or the other. I talked about solving harder ones, right? We looked at some examples where we solved quadratic equations that had x squared and x terms, and the only way we really had to do that was to factor them and use the zero product property, right? Which sometimes works and sometimes doesn't. It's a great strategy if it's easy to do. Not going to work well here, though, is it? Because, well, I'm not going to say it's not going to work well, but we can do something easier. How come? Why is this problem easier than the other ones we looked at previously? What's easy about it? Okay, good. We can very easily rewrite this equation or simplify it so that it's only got a single x in the whole equation, right? And that's good for us because what do we always say? If we can point to a single x, then we can isolate it. Good, right? So we got one step. What's that going to be, Carolyn? What did you say to do? Good. We want to push the x squareds, collect them on the left side because we'll have a positive number of them there, right? So we'll just subtract x squared from both sides, and that gives us how many x squareds on the left? 1. Good. So 2x squared minus x squared is just x squared plus 5 equals negative 11. That's better, right? So now we've got this thing simplified. So I can point to a single x. So all I've got to do is just work backwards through order of operations, right? So what's the first step I'm going to do to get the x squared by itself? Good, I'm going to subtract 5. So first I want to undo any loose addition or subtraction outside of parentheses, right? So we'll subtract 5 from both sides, and that's going to give us x squared equals, what's negative 11 minus 5, or negative 11 plus negative 5? Negative 16. Okay, now are you thinking ahead here when we square root it?
Yeah.
Okay, so what is, Bailey, what's next then? So we're going to square root it, good. So we go upwards through our steps here. We already took care of step 1. Step 2, is there any loose multiplication or division? No, there's not. Nothing to deal with there, right? But step 3, we get to exponents. And yeah, we do have an exponent that we've got to undo. So we undo x squared by just square rooting both sides, right? We all know that. But there's something really important that we always have to do without even thinking about it. We just know this has to be just second nature or just kind of, deeply ingrained in our algebra knowledge. When we solve an equation by square rooting both sides, what do we always have to include? Plus or minus. Good. So we end up with x equals plus or minus the square root of negative 16. Okay, but there's something else here this time that came up that we just talked about last week, kind of introduced. What's weird about that square root? It's got a negative in there, right? So that's not going to give us a real result, right? We've always been taught you can't take square roots of negative numbers. And you can't if you want to get a real result, but you can if you're okay with an imaginary result, right? What do we do to that square root of negative 1 times 16? How do we change that? Put an I, that's it, right? We just rewrite this as plus or minus I times the square root of positive 16, right? And so that I means, yeah, it is going to be a weird imaginary answer, but we can still get an answer, right? What is the square root of 16? 4. So our answer then just looks like plus or minus 4I. Okay, and so what would we put in Moodle? We have to separate our solutions by commas. So what would we put? 4I, comma, negative 4I. That's it. Okay? Questions? Okay? One more of those. And just a quick reminder, remember we looked at this? Just a quick reminder about these complex numbers, what we're dealing with here. Remember that all the numbers you've ever dealt with prior to this math class probably have been real numbers, right? They haven't had any i's attached to them. But now we're looking at something different. We're looking at numbers that do have i's. If the number if it's just some number times I, then that's what we call a pure imaginary number. But both of those are just subsets of the larger set of all possible numbers, which is complex numbers, right? So real quick, remember that complex numbers are always, the standard form for a complex number is a plus bi. What do we call the a? Do you remember? What do we call just that a? There's two parts to an imaginary number. That was, which part was this? Let's get rid of, if there's any earbuds or anything or phones, please get rid of all that stuff. What's that going to be? Is that the real part or the imaginary part? That's the real part, right? Because there's two parts to it. There's a part out here that's just a real number, and then there's a part that's got an I with it, so that's the imaginary part, right? So A we call the real part, and B, which is the number being multiplied by I, we call the imaginary part. Okay, and I'll give you some more reasons why that works on Wednesday. I'll show you some cool stuff. Did I give you any examples of why those are useful? I didn't. Okay, Wednesday remind me to do that. There's some kind of cool physics examples where I'm not going to take you through the whole thing, but I'll just describe some places where this is really helpful. Okay, these imaginary numbers. And so all the real numbers, every number you've ever dealt with, they've all been complex numbers. But what's been true about the imaginary part B? Have you ever had an I in an answer before? Never have, right? So all the numbers you've ever dealt with, what must the value of B been?
0.
0, yeah, because 0 times anything is 0, right? And so A plus 0 times I is just A, isn't it? Right? So for the set of real numbers, it's just the set of complex numbers where B is equal to 0, the imaginary part. What if you get a pure imaginary number that's only got a number of times I? What's equal to 0 there? A, yeah. But in general, this is what every number really is, right? Every number is really just a complex number. These are just some specific subsets, right, of that larger set of complex numbers. Okay, so let's look at one more example, and then I'm gonna let you work on this stuff. So what about this then? How many, can you point to a single x here? You can, right? If I look at this equation, there's the variable x only shows up once right there. So I should be able to just work backwards through order of operations and isolate that x. It looks like there's a lot of stuff going on, but you'll come to realize that these are just really not very hard. I mean, just follow that backwards, that routine of working backwards through those set of steps, and you're guaranteed to get the right answer, right? You do each step correctly. So what's the first thing then? We've got an x that we can point to so we can isolate it. What's the first thing that we need to do? Subtract what? 2. Yeah, we subtract 2 from both sides. We want to undo any addition or subtraction of loose terms. Well, there's a loose term. That term is not, it's separate from the parentheses, right? Outside of the parentheses. So we could just subtract 2 from both sides. And that gives us 2 times the quantity x minus 3 squared equals what? Negative 60. Good. Okay? Good. So we made it through the first layer. What about the next layer? Okay, divide by 2. And this is really important. Remember, there's what you don't do. There's a real common tendency to want to distribute that 2, but you can't do it. You can't do it because this quantity is being squared, right? So it's not, that's going to give you a wrong answer. So instead, we're just going to always look to see if there's any loose multiplication or division, any multiplication or division outside of the parentheses, which we don't get to until the end, right? So here are our parentheses. Yeah, the 2 is being multiplied outside of the parentheses, right? So we'll divide both sides by 2. So the 2's cancel, right? And what are we left with on the other side? Yeah, negative 8, good. Okay, so we've made it through the second layer. What's next? Exponents, yeah. So we got a square root now, right? I'm going to square root both sides to undo that square. Okay, so if we do that, what's the first thing I've got to write? So that's going to give me, I get rid of the squared, so I just get x minus 3. Technically, it's still in parentheses, but do I even need them at that point? No, don't even really need them. So x minus 3 equals plus or minus. Good. Before I even do any thinking, I just reflexively remember I got to put that plus or minus there because I square rooted both sides of an equation, right? And then I get the square root of negative 8. So what's the next thing I do right away? Make an I out of it, right? I take the negative 1 inside the radical, and I'm going to write that as an I outside the radical. And now I've got a regular old positive 8 inside the radical. Can that be simplified? It can, can't it? What's a perfect square that divides evenly into 8? 4. Good. So I could break this up into the square root of 4 times the square root of 2. And what's the square root of 4? 2, right? So I could make this plus or minus I times 2 radical 2. But what we really want to do here, and this isn't going to make it wrong if you don't do this, but we really like to put constants like I or pi or anything like that. We put those after whole numbers but before radicals in math. It's just kind of a convention. Just so we don't accidentally make a mistake and put the I after the radical, which sometimes looks like it's inside the radical. Right, so we don't like to put stuff at the end if there's a radical there, but normally we would put the numbers first and the constant second. So that I would go in the middle. But if you put it at the end or out in front, it's not wrong. It's still going to be marked correct. So now, last step. What's the last step? So we've got, let me rewrite this. So we've got x minus 3, technically was in parentheses, we don't really need them anymore, equals plus or minus 2I times the square root of 2. What's the last step? Parentheses. Well, okay. Those used to be the parentheses. So I finally made it up to the parentheses. What's the last thing I have to do to get that x by itself? Add 3. Because on x minus, I got to undo subtracting 3. So we'll add 3 to both sides. And where we want to put that is in front of the plus or minus. So we're going to get 3 plus or minus 2I radical 2. Okay? So if I split those up, the plus and the minus, those are really just two different complex numbers, aren't they? Right? So what's one thing I could, in Moodle I've got to separate my solutions. So what's one solution I would input? 3. What? Well, okay, there's more than that, right? Because I've got 3 plus or minus this stuff. That's an or statement, right? So I've got to do both of them. So one of them is going to be the plus sign. So I'm going to get 3 plus 2. I'm going to write this incorrectly for a second so you can just see that it's easier that it's a complex number. 3 radical 2 times I. That's just a complex number, isn't it? Right? What's the real part of this complex number? 3. That's the number that doesn't have an I with it. What's the imaginary part? 2 radical 2, right? 2 times the square root of 2, because that's what's being multiplied by I. So that's one solution. You know, technically that I probably should go in there, but you know, once again, you're not going to get it wrong if you don't. What's the other one? Yeah, 3 minus 2 times the square root of 2I. Okay, that's it. Make sense? Okay. I'm going to call her quits there. I'm going to add one more short assignment that's going to have you do something like this. But then that's all I'm going to, and that won't go on progress reports, but I would like you to maybe do like a problem from that sooner than later so you don't forget this stuff.